How's it going, everybody? In this video, we're going to be continuing in our Security V5 written exam for CCIE Security. In this particular video, we're going to be hitting VLAN ACLs and port ACLs and how they come into play and stuff like that. And we'll go from there. Now, as we get into this, it's important to understand why you would use either one and how they come into play. So we've already talked about dynamic dynamic shrinking protocol, and we've also talked about port security. Well, as we progress forward here, the VLAN ACL and the port ACL. The VLAN ACL, or the VACL as it's commonly referred to, is an attempt to control access within a VLAN. So normally you're not going to be able to do that. So any type of any communication within a VLAN between two hosts in a VLAN is going to be permitted by default, and there's not a whole lot you or I or anybody else can do about that for the most part. So the VLAN ACL was created to help get around that issue. Now the idea is to filter layer 3 traffic on a layer 2 switch. So the idea is when you have two hosts in the same subnet in the same VLAN. And now here's the caveat that I often find with folks that are just getting into the networking space. Most of your senior level people that have been doing Cisco for at least a couple of years would understand that a VLAN is just a broadcast domain, and the subnet or the IP, the /24, the /26, or whatever it is that you might be deploying in that VLAN, you can have multiple subnets residing in that VLAN. And that's the benefit here, because at the end of the day, you're just creating a broadcast domain. The switch or the router, because of the fact that you can use secondary addressing, doesn't really care what the IP address is. So you could have a 192.168.10.0/24. You could have a 172.16.31.0/27. I mean, you can have pretty much any variation you want as you're going along. Now the benefit to that is it gives you a little bit of scale. You don't have to create a new VLAN for every prefix that you need to deploy. And that's the benefit here. Do this also can be a problem when you're trying to mitigate any type of communication within a VLAN. Normally the only way to do this is with private VLANs, or doing some sort of micro segmentation where you're trying to get down to the service level. Like when I say a service level, I'm referring to 10.1.1.1 can't talk to 10.1.1.2 via port 80 or 443 or 8080, something along those lines. With the VLAN ACL, we're not really able to get that granular, and normally you don't want to, because if you start getting that granular, then it gets difficult to manage. And if you block too much, then you have to scale back, and then you're sitting there trying to figure out, okay, what level of filtering is appropriate for this type of design. So normally it's not too terrible. If you've been doing it for a while, it's pretty easy to figure out a design and a solution for that. But in this particular case, you're breaking down traffic as it's transiting within inside of the broadcast domain. So the easiest way to do this is with an ACL, and the ACL is created, the logic in the ACL is what actually does the filtering. And then what we're going to use is a permit statement in the ACL. You might say, well, why would I want to permit it if I'm planning on denying it? Well, the reason for that is because with the VLAN ACL, you're not actually using the access control list entries as a way of determining true or false. And if it's a true, which is a permit in this case, the VLAN ACL uses what they call a Vlan Access Map, and the Vlan Access Map acts like a route map with sequence numbers and permit and permit and deny statements per entry. So the idea when I'm configuring this is if I'm going forward with my config, I am going to create an ACL named whatever. So you can get granular if you want in the ACL. So for instance, you could block RDP access, or you could block web access or FTP access. You could block pretty much anything you want that the ACL can match on. And the ACL can be a standard or an extended ACL. The ACL logic is what you're trying to is what you're matching against for your true or false. So, for instance, you could have an access list that is configured to permit TCP traffic from any source to a given host on any port that TCP might be used on. 80, 443, 3389, 21, 25. They all, any TCP port that's used out there for a semi-well-known or well-known application can be used. Now the VLAN ACL, or I'm sorry, the VLAN Access Map comes into play. And then like a route map, it is numbered sequentially, 10, 20, 30, 40, etc. And every sequence number gets an action, whether that the action is drop or whether the action is forward. If the action is drop, then obviously it's going to get dropped. This is where in normal ACL logic, you go through the process in a top-down fashion. So the very first match, you stop processing the ACL. The same thing with the route map. The VLAN access map is no different. So you start at the top and you work your way down. So it's very important that you have your more specific matches at the top so you get hit at the top. So look at it this way. If I start at the top with sequence number 10 and I configure the action to be drop, and then I say, you know what, I'm going to match on IP address and whatever the VLAN, whatever the access list number or name is. Once you've done that, then you need to create another sequence with action forward. What that's going to do is bypass everything else and say, you know what, here we go. Now, the access list itself is only checked on sequence number 10. So if we draw this out, let's go ahead and bust out the pen pad here. We draw this out. So the idea here is if I have an ACL with, I have an ACL, and the ACL's logic is permit TCP from any source to a destination of 10.1.1.1 equal to 23. Let's say I want to drop telnet, or I want to match on telnet. This is what you're doing. You're matching on telnet in the ACL. Then you come over to the VLAN access map. So you type in VLAN access map, and then you would give it you would name it, so name, whatever that might be, and then you would give it a sequence number. In this case here, I say 10. The action, in this case here, would be drop. Now, if I left it just like this, that would be a bad day, because it would match on the TCP connection and everything else, because there's nothing else there for it to work with. It would drop everything, right? This would be like a end of the world scenario. I would come in here and type in match IP address, and then I could say whatever the ACL's name or number is. So I could say, let's assume that we said ACL 100 here for the sake of argument. 100. Just like you would in a route map. No different there. The only difference is when where in a route map the sequence number has a permit or a deny. So you're using the access map to deny the traffic, not the ACL to deny the traffic. And that's the caveat here. If you deny the ACL, it's a negative filter, which means it gets bypassed. So if I go in here and drop, you could have inconsistent results. I haven't tested it out, so I have to be a little careful on how I say this, but the idea here is if I go here and I permit TCP any to 10.1.1.1 equal to 23, I'm expecting to match on this. So then I come in here, I drop in this, but then I have to create another sequence below this. And then whatever the name might be. And then I would say 20. Sorry, I apologize about my handwriting. And then you would say action forward. This would be the same thing in a route map of saying route dash map 20 or route dash map drop telnet sequence 20, and then you would, or permit 20. You would deny in a route map 10. So route dash map drop telnet deny 10, and then match IP address 100. And then in route dash map drop telnet permit 20, you wouldn't match on anything. So which would be match everything. If you don't match something, it matches everything. And then to round it out, you would use the Vlan filter command, and then this you would call the name of the access map. So you would say name, and then you would specify the VLAN list. So the VLAN list is the actual VLAN you're applying this to. So we'll say VLAN 10. By typing all of that in, what you're actually doing with the logic of this, the very top is permit TCP any from any source to the destination 10.1.1.1 as long as the destination port is 23, which is telnet. Then in the access map, your first sequence number is 10, your action is drop, and your match IP address 100. Now you're matching on traffic from the ACL. And if the ACL is a match, which means the permit statement there makes it a true statement. If it was a deny, it actually wouldn't get processed because it would have been a negative or a nil or a null or whatever, and then it wouldn't get processed. And then you'd pass it on through. So the idea here is you have to be careful when you're configuring this stuff. Maybe you have to play around with it a little bit, because depending on the situation at hand, if your logic is illogical, I know that's kind of backwards, but if your logic is illogical, if you are denying where you need to be permitting, then you can have inconsistent results. Now, normally if I know I'm going to be using a route map, I always go with a permit in the ACL, but a drop in the route map, because I know the logic, and it depends on what it is that I'm working with. So, because there's a big misconception on how this actually works with route maps, and so think of it like this: the route map is an if-then else statement, right? It's a logic, if you will. It's a wrapper. So the wrapper takes the in the route map sequence dictates the action. So in this case here, we're saying a drop, but instead of the action drop in a route map, it would be a deny next to the sequence number, right? By default, it's a permit 10. If I deny in the ACL and then I deny in the route map, what do you think happens? Legit question. It permits the traffic. It is being denied from being denied. A negative times a negative, in this case here, is a positive. It forwards the traffic. Now, one of the things that I find interesting, and this actually is, I had to sidebar here and go off on a little tangent just for a moment. When you're referring to how this stuff comes into play, there's a big misconception about when to use an access list and when to use a prefix list. So, if you are trying to block traffic in the data plane, you're trying to match some sort of TCP flow or UDP flow from a source to a given destination, you're trying to match something in the layer 3 header or the layer 4 header, then an ACL is the appropriate filter to use. The reason why is because it's actually looking at the payload. or it's looking at layer 3 and layer 4 information. Source and destination IP, source and destination port, and the transport. Those are the technically the 5 tuples. So if you don't know what a tuple or a tuple is, it's a pairing of information. So you have your source and destination IP address, you have your source and destination port, and then you also have your transport, TCP or UDP. Now, when you have that logic broken down like that, in the ACL, I can get granular with an extended ACL. I can go in, I can say, okay, if the traffic is coming from this, is TCP as the transport, and it's coming from, I don't care where, so any, going to 10.1.1.1, and the destination port is set to 23, which is the telnet service, assuming that the telnet service is running on 10.1.1.1. If it's not running, you're going to get a port unreachable because it can't connect to that port. It can reach the IP, so you're going to get a host. The host reachable is going to come back as a positive, but your port unreachable is going to come back with an unreachable or a nil value. I couldn't talk to that port. Now the port could be open, but the service could be down. This is where I had to troubleshoot networks day to day, and this is normally where I end up having to go, okay, well I can telnet from where I'm at to 23. Now, all that's doing is it's proving that the port is open and that there's something on the back end that's accepting that connection. If I get to that point where I can ping the IP but I can't open that port, like for instance, one of the common things that I test is web and HTTPS. So 80 and 443, I sometimes do it for 21 and 25 for SMTP and for what was the other one I mentioned? FTP. So what I'll do is I will send telnet connections to those source port or to those destination ports, and if I get it open, then that tells me that the service on the back end is working. If I don't, then I know it's getting dropped. Now that's all transport traffic, data plane. The flip side of that is control plane. Now the control plane portion of it, if I am trying to use a route map to filter incoming information from a routing protocol appearing, then I'm going to use a prefix list, because the prefix list is going to allow me to match on the prefix and any variation of a prefix inside of that. So let's say for instance I'm peering everywhere with 172.16.00/16. So pretty much way more of the 172.16 range than you need to, but anyway. The idea with the prefix list is I don't care what the transport is. I don't care how the network is flowing. I don't care the data flows. I don't. I'm not looking for NetFlow related information. What I'm caring about is, can 10.1.1.0/24 be reached? If I don't want it reached, I'm going to use a prefix list to deny that traffic and then permit other things. So I'm not going to get into how all that type of stuff works or the logic on that piece, but that's basically how that comes into play. Now, as we proceed further here, the next topic we're going to talk about is going to be the port ACL. And this is another one of those things where if you understand how the Vlan ACL comes into play, then the port ACL is going to be pretty much the same. The difference between it, the Vlan ACL matches on layer 3 traffic in a layer 2 network. So you have a broadcast domain between two endpoints and you're dropping layer 3 communications. Now you could be generic with a standard ACL, or you can be very granular with an extended ACL. The choice is yours. With a port ACL, you are filtering layer 2 traffic inbound and inbound only from a source. Now you are going to be using what they call a MAC access list to do this. And the MAC access list works very similar to that of an ACL, which is what it is. The MAC ACL is simply going to match on a MAC address. So I can specifically state that if I want to, for instance, I've never tried this on a trunk link, but my assumption is it would work very similar to that. The idea is if I have a situation where I want to be able to prevent any communication from a particular source or a destination or a combination of the two. If I want to deny, say for instance, the host MAC address of 000000001 from being able to talk to 0000002, I can match specifically on that. I can say deny host 0000001 and host 00002, and then put another entry in there to say permit. And then if I do that, I can go to the interface level and type in MAC access group and the name of the MAC access list inbound. You can only filter inbound with the MAC access list or the port ACL. Now this is what they commonly refer to as IP source guard, or one variation of it. There's other things called URPF, or unicast reverse path forwarding, for both strict and loose mode, where you are trying to mitigate issues when it comes to layer 3 forwarding, typically over the internet. But the PACL and the VACL are going to be very, very similar operations. Their application is different and their use is different, but they both use an ACL and they both are trying to lock down traffic in a layer 2 broadcast domain. Now, I've never seen a MAC access list used in production. Not to say that you can't do that. Actually, that's not 100% true. I have seen them used in some environments. Actually, it's just one, now that I think about it. Only one environment that I've seen it, and it was just to block, I think it was Bonjour, on a switch port that connected to a Mac Pro, I believe is what it was. And I don't know why they used that. I don't know much about the Bonjour protocol other than the fact that Apple uses it. So I don't know what the driver behind that was. But I remember seeing the config and going, oh, that's the first time I've seen that. I've seen VLAN ACLs used a few times here and there to try to do like a poor man's network microsegmentation. So let's talk about that just for a moment. Microsegmentation versus macrosegmentation. What does this really mean? Well, I'm going to give you the 2-minute, this is what I think it is, because it kind of relates to what we're talking about when it comes to VLAN ACLs. So macrosegmentation, macro meaning big, micro meaning small. So a macrosegmentation is going to be any type of segmentation on a larger scale. This could be, you have to define what you think macro is. Now macro could be subnet to subnet. So if you have a router with 2 sub-interfaces and you can, you want to prevent, I'm seeing this more and more in hybrid multimedia environments. And what that really means is your Cisco, maybe you have a Cisco phone with a camera on it. I think the DX80, it's like an Android desktop-based phone system. I don't know much about it. And you've got this device here, and you've got somebody else with a phone, and then you got a third person over in the corner that's got a webcam on their PC. Well, for hypothetically speaking here, the DX80 and the PC user might be sitting in the same VLAN, where the person with the phone's sitting in a different VLAN, because you're typically going to segment off voice from data. Well, this would be a perfect example of where like a macro segmentation would come into play, because you're trying to filter between VLANs or between subnets, or potentially between modules in the network. You're trying to segment your data center from your user network, or your data center from your internet edge, or your private WAN. Whatever you want to, however you define and carve that up is up to you. That's why design is kind of, it's subjective in how you approach it, because I've talked to plenty of people that are, multi-time CCIEs and CCDEs. I've had the pleasure of meeting a lot of people that are much more skillful than I am when it comes to this type of stuff, and I end up having this. it's more of a it's a technical debate. Like, okay, well, how do you validate this or validate that? At the end of the day, macro segmentation versus micro segmentation, in my opinion, macro segmentation is between VLANs. Micro segmentation is within the same VLAN. So if I'm doing macro segmentation, I'm trying to prevent potentially the user on the phone from being able to access the printer on the other VLAN. Now, there's no reason the phone should ever need to print, at least in my opinion. I don't know if it's even a possibility, but that's more or less the mindset. Where it is possible that the user, the phone, would need to talk to call manager, or whatever it is that the phone would need to talk to. That is legitimate. So I would try to build a macro segmentation policy that would meet that endpoint's needs, and that's kind of the drive I would see that. On the flip side of that, you would have a situation where with the micro segmentation, you've got the two PC users, you know, the DX80 and the PC, that are talking to each other through, like, I don't know, Skype for Business or WebEx. You've got them communicating back and forth, but you don't want the DX80 to be able to do a search of the PC user's desktop. So you might block SMB or whatever other application might be out there to scan a Windows environment. But these are the type of things where you've got, it's very subjective, but this type of stuff right here is, the Vlan ACL specifically is a micro segmentation of sorts, because you're trying to prevent a specific type of traffic from being able to go from one source to one destination via a specific flow to a specific service. And that's microsegmentation. At least in my opinion, that's what it is. But I don't want to get into a debate or, well, I mean, if you have a difference of opinion, please feel free to drop it in the comments. This is just what I think, you know, and segmentation itself is, like I said, is very subjective. I've had multiple conversations with people of all skills and opinions. They're mostly the same for the most part. You know, people think micro, macro, they kind of define what's going on, but it usually needs to be just their idea or their perspective of that particular feature just needs to be narrowed down just enough to where, you know, I can understand what it is you're trying to prevent from happening and build a policy to meet that. Because if your requirements are too generic, I can come up with a solution and propose it to you, like I've done many times, and you may not agree with it, or I'm gonna go, well, you missed the bullseye, Rob. Like, well, okay, well, what did I miss? Well, I wanted this. Well, you never said anything, so how was I supposed to know? So having having that conversation definitely does help to try to understand what that person's perspective and point of view is, and that's really important. And not just from a design perspective, but from security as well, because there's other techniques that are out there nowadays, like security group tags and stuff like that, that are available to us, and ICE with its ability to block users from being able to gain access to certain things and stuff like that. So the ability of being able to go in there and filter on traffic and see what's going on, that's a really big deal. And we're going to see more of that when we get into things like firepower later on. I've actually been doing, when I'm not recording videos for this, I'm actually doing a deep dive on firepower right now, and holy cow, is it awesome. I'm blown away at what you can do with firepower. So I've got it in a POC right now. I'm labbing it up right now. Matter of fact, on my other screen, I've got the FMC pulled up. So you guys will be, we'll definitely be talking about how that goes. And I'm super excited about actually recording CCIE content for that and actually walking through demos and stuff like that. So very cool stuff coming. So I want to try to give you little tidbits of stuff that's coming. At any rate, guys, thank you so much for stopping by, and we'll catch you guys in the next video.